Good morning, students. So, in previous lecture, we have studied about the knock in a engine, okay, and what are the different factors that are affecting on the knock, okay. So, this was the last factor, that is fuel air ratio, okay. So, what is actually this fuel air ratio? This is a composition factor, okay. The flame speeds are affected by fuel air ratio. Also, the flame temperature and the reaction time are different for the different air fuel ratio. Okay, and that already we have discussed. Maximum flame speed and the temperature is obtained when this equivalence ratio, this phi is nothing but your equivalence ratio, which is 1.1 to 1.2. Okay, so we have to continuously maintain this particular uh, flame speed of the this particular equivalence ratio, so that there will be no knocking. Okay, now let us discuss about the octane value of the fuel, and this is very much important. Again, this is the important concept which may ask in the examination. So we will discuss in detail about this octane value of the fuel, okay, or the octane rating. So a higher self-ignition temperature of the fuel and a low pre-flame reactivity would reduce the tendency of the knocking. In general, paraffin series of the hydrocarbon have the maximum and the aromatic series of minimum tendency to knock. Okay, so this paraffin series have the maximum tendency of the knocking, and aromatic series have the minimum tendency to the knocking. Okay, the naphthene series comes in between the two. Okay, now let us discuss the summary of the whatever parameters we have discussed up till now, which are affecting on the knocking in a site. Okay, so let us see increase in variable. So if you increase these particular variables, what will happen? Okay, so the major effect on unburned reduced charge. Let us see this, and action to be taken to knocking. Can operator usually control or no? Yes or no? Okay. So first parameter is compression ratio. So what is the major effect on unburned reduced charge? So increases temperature and pressure, and therefore action to be taken. What we have to do? We have to reduce this compression ratio. Which can operator usually control this? So no, it cannot be controlled. So remember, to avoid the knocking, this compression ratio must be reduced. Mass of charge inducted. So this also must be reduced. What is the effect on the unburned charge? It increases the pressure of the end gas, and that's why increases the tendency of knocking. That's why to avoid the knocking, we have to reduce it. So it can be controlled. Okay. So inlet temperature. What is the inlet temperature? If the inlet temperature increases, okay, that means if this inlet temperature increases, definitely increase in the temperature of the end gas, and therefore knocking will increase, and therefore what we have to do? We have to reduce it. So in some cases we can control. Chamber wall temperature. So definitely when this increases, temperature increases, and we have to what action we have to take? We have to reduce it. Spark advance. If the spark advance increases, so there it will definitely increase the temperature and the pressure of the end gas, and therefore what we have to do? We have to retard the spark advance. So whatever we are doing the sparking advancedly, so we have to let spark do the sparking late. Okay, that is called as retardation of the spark. So in some cases we can control it. Now air fuel ratio. So if air fuel ratio increases, okay, if air fuel ratio increases, then what will happen? It increases the temperature and pressure, and therefore we have to make it very rich to avoid the knocking. In some cases we can reduce it. Turbulence. Definitely turbulence will increase the flame speed, and therefore decrease the time factor, and therefore what we have to do? We have to increase the turbulence. Okay. Engine speed. Engine speed we have to increase definitely. Okay. So to increase in engine speed, decrease in time factor, and therefore increase what we have to action we have to take? We have to increase the engine speed. Distance of flame travel. So if the distance of the flame travel increases, definitely what will happen? Increase in the time factor, and therefore the knocking may takes place. So what we have to do? We have to decrease the flame travel distance. Okay. So action we have to take is we have to reduce it. So we cannot control it. and this engine speed we can control. Okay, so this is the summary of the different factors which you can remember only these particular factors also, and you can write in the examination. Now let us see again very important point, which will be the last point here, okay, in the SI engine, that is combustion chambers for SI engine. So first of all, actually studying the types of combustion chambers that are used, first of all you will see what are the different design uh, parameters, or what we have to do consider different parameters while designing the combustion chamber, and after that we will see the types. Okay, so the design of combustion chamber for an SI engine has an important influence on the engine performance and its knocking tendencies. Okay, the design involves the shape of the combustion chamber, the location of the spark plug, and the location of the inlet and exhaust valves. Okay, so these are the designs involves. Now, the important requirement of an SI engine combustion chamber are to provide high power output with minimum octane requirement, high thermal efficiency, and smooth engine operation. Okay, so from any engine we expect these particular three things. Okay, high power, high thermal efficiency, and smooth engine operation. Okay, so these are the basic requirements. Now let us discuss how, on which factor the smooth engine operation depends. So smooth engine operation means what? The aim of any engine design is to have a smooth operation and a good economy. So this can be achieved by the following. How to achieve this smooth operation? By keeping a moderate rate of pressure rise. So limiting the rate of pressure rise as well as the position of the peak pressure with respect to TDC affect smooth engine operation, right? Next parameter is reducing the possibility of knocking. So how to reduce the possibility of knocking? We have already discussed. So reduction in the possibility of knocking in an engine can be achieved by reducing the distance of the flame travel. Means what? By centrally locating the spark plug and also avoiding pockets of stagnant charges. Next point is satisfactory cooling of the spark plug and the exhaust valve area, which are a source of hot spots, okay, and which may lead to the knocking. Reducing the temperature of the last portion of the charge. So how to reduce this? Through application of a high surface to volume ratio in that part where the last portion of the charge burns. Okay. And the third point is high power output and thermal efficiency. So that is again requirement of the engine. So how this can be achieved? So a high degree of turbulence is needed to achieve a high flame front velocity. That is, turbulence is induced by inlet flow configuration or squeeze arrangement. What is meant by squeeze? Squeeze is a rapid radial movement of the gas trapped in between the piston and the cylinder head into the bowl or the dome. Okay. Squeeze can be induced in spark ignition engines by having a bowl in piston or with a dome-shaped cylinder head. Okay, so these are the different factors or the different considerations that we have to look before going to the design of the engine or the combustion chamber for SI engine. Okay. Next is we require high volumetric efficiency. So how to achieve this high volumetric efficiency? So more charge during the suction stroke results in an increased power output. This can be achieved by providing ample clearance around the valve heads, large diameter valves and straight passages with minimum pressure drop. Okay. Improved antenna characteristics. So improved antenna characteristics permits the use of a higher compression ratio resulting in increased output and efficiency. Okay. Now let us discuss about the types. And one more factor, that is a compact combustion chamber we required. Okay. So reduces heat loss during the combustion and increases the thermal efficiency when we design the compact combustion chamber. So these are the advantages. Different types of combustion chambers have been developed over a period of time. Some of them are shown in figure. Okay, so look at this here. T head, L head, I head, and F head. So to remember this, you just remember this word, that is lift. I think everybody can remember this, right? Lift. What is lift? L head, I head, F head, and T head. Okay. So let us discuss about this T head and this. What is T head? So if you see here in this case, so this shape of the combustion chamber is like T. So here there is a spark plug, exhaust and inlet wall. So inlet wall and exhaust wall are on the both sides, either sides of the particular this cylinder. मतलब यहाँ पे एक इधर एक इनलेट वाल है और आपका यहाँ पे एग्जॉस्ट वाल है, ठीक है. So the T head combustion chamber were used in the early stage of the engine development. Since the distance across the combustion chamber is very long, knocking tendency is high in this type of engines. Remember, this configuration provides two valves on either side of the engine, requiring two crankshafts. Camshafts. आपका देखो इधर इनलेट वाल इधर है और एग्जॉस्ट वाल ये साइड में है, तो दोनों को ऑपरेट करने के लिए आपको क्या लगेगा, यहाँ पे कैमशाफ्ट अलग अलग लगेगा. एंड दैट इज द डिसएडवांटेज ऑफ दिस इंजन. फ्रॉम द मैन्युफैक्चरिंग पॉइंट ऑफ व्यू, providing two camshafts is a disadvantage. So this is the drawback. Now let us discuss about the L head. So the shape is like L. Okay, look at this. This is the L head. So spark plug is here. Okay, and inlet and exhaust wall are on the same side. So this is the advantage. So a modification of the T head type of combustion chamber is L head type, which provides the two valves on the same side of the cylinder, and the valves are operated by a single camshaft. Okay. The main objective of the Ricardo's turbulent head design, that is figure number C. This is called a Ricardo's turbulent head. That is again a shape L shape, but what they have modified this particular portion, if you see here in this case and in this case, the shape is changed. Okay, if you observe this. So what is the purpose of this? Axle to obtain fast flame speed and reduced knock. Okay. Next is I head. So in L head we have to explain this too. Okay. In I head the shape is like I. Okay. So that's why this is called I head. So inlet and exhaust wall are on top and spark plug is side. Okay. At the side, in which both the walls are located on the cylinder head. The overhead wall engine is superior to a side wall or an L head engine at high compression ratios. So if you require the high compression ratio engines, then we have to go for I head. Some of the important characteristics of this type of engines are less surface to volume ratio and therefore less heat loss, less flame travel length and hence greater freedom from knock, high volumetric efficiency from the larger valves or the wall lifts. So this is the advantage. And if, remember this is very simple diagram. And last is F type. So if you see here, the shape is like F. Okay. So here is inlet wall, here is exhaust wall, inlet wall, and here is the spark plug. Okay. So the F head type of wall arrangement is compromised between L head and I head. Okay. Combustion chamber in which one wall is in the cylinder head and the other in the cylinder block are known as F head combustion chamber. So this is cylinder head and this is cylinder block. Modern F head engines have exhaust wall in the head and inlet wall in the cylinder block. The main disadvantage of this type of engine is that the inlet wall and exhaust valves are separately actuated by the two camshafts mounted on the camshafts driven by the crankshaft through the gears. So this is the disadvantage. So we require here two camshafts. Okay, and that is the disadvantage. So I hope you understand the types of combustion chambers that are used in this SI engine. Okay, so just remember the word lift, L-I-F-T. Okay, and just you have to remember the sequence, T-L-I-F. Okay, so thank you very much. We will see next in next lecture CI engine. Okay, combustion in CI engine.